Power on the projector, please. Fine. In last class, means yesterday's class, we have studied about network layer. In network layer, we were discussing about few points like it forms data packets. It adds a logical address with our data frames, which comes from the data link layer. And few more features like transition between IPv4 and what? IPv4 and IPv6. Fine. Mapping is also done at this layer. Then internetworking is also the process of network layer. Fine. IP routing is also. And finally, this network layer is responsible for transmission of data from source network to destination. Fine. In all these things, first of all, we have discussed about data packet. Data packet, actually data packet is a IP packet. That's why this is known as data packet. Because if data frame is coming from data link layer, then it has only MAC address. But at network layer, logical address is attached. Now it becomes data packet, or you can say IP packet. But sometimes there is a question, what is IP packet? What is the meaning of IP packet? Just see an example. Because I have seen university has asked a question in university exam. What is IP packet? You have to explain it. That's why. Look, in your CCNA paper, you have studied that. Suppose this one is one router, this one is second. I am just drawing um, uh, a network design which has only two networks, two different networks. Fine. In this case, suppose there is a network of 10, there is a network of 172.16, and for linking these two routers, there is a network of 11. Now, this node is trying to send some data to this node, and its IP address is, for example, 10.0.0.2. Fine. And this node's IP address is 172.16.0.2. First of all, a data will be transferred from this node to this switch. Fine. And switch handles only frames because it works on MAC address. Very good. Now, this switch is unable to find the node that is 172.16.0.2. Then, this switch transferred this data packet to this router. Fine. Now, what will this router do? No. If there is a data packet, this one is data, and this one is a address field. Address. Fine. In this address field, source address and destination address. Fine. In source, suppose its MAC address is A and its MAC address is Z. Just imagine A and Z. Fine. A MAC address is available, Z MAC address is available. But in this data packet, IP address 10.0.0.2 is also available. Fine. And for destination, it has 10.0.0.1. Then definitely your data packet will reach at this point because this is the gateway IP. We have used this type of diagram. We have done practicals. Fine. And we have successfully pinged this machine from this machine. But now, this is the IP address. If this router gets this packet and checks about the destination address, then in this destination address, only this is the address 10.0.0.1. Fine. Then what router will do? Router will not route it because router provides communication between two or more different networks. Fine. So this packet should have an IP address of this node 172.16.0.2. Fine. Now, if this packet will take this IP address Then, as per the process, this node will try to find this destination node in this network, but switch will transfer this data packet to this router, and router will check this IP address, and if route information about this network is available into its routing table, in that case, the router will transfer this IP packet to next hop router. Next hop router means just next router. Now, in this case, next hop router is this. But for transferring this data packet to next hop router, there should be a change. There should be a change. Then that change is next IP 11.0.0.2. 2. This one is 11.0.0.1 and this one is 11.0.0.2. Fine. Now, our data packet will be transferred to from router 1 to router 2. Fine. Now, at router 2 will again check it. Then the actual communication should be with this node. This network's information is, if available in this router, then this router will transfer this data packet to this particular network. Network means 172.16.0.0. This is the network IP. Fine. Now, if this router will check it, then it gets an information. Yes, this network information is also available in my routing table, and this is my own network. So router will transfer this packet to this interface, and then data packet will come to this switch, and again switch will work as its own nature. Right, MAC. Finally, data packet becomes frame, and frame will be accepted by this node. But have you seen there are many changes? I'm just giving. Have you seen there are many changes? It is too much confusing for us. Initially, IP was this, then this, then this, and then finally, finally Z. Look, MAC address is not changing, but IP address is changing again and again. The summary of this diagram is this. MAC address is not changing. It is fixed for source and destination, but IP is changing for transmission of data packet from one node to next node. Fine. This change is done with our IP data packet. Yes.
So if data packets transferred from R1 to R2, then maybe it can be possible data packet lost.
Definitely it is possible. Definitely it is possible. Data packets can be damaged, can be lost, acknowledgement may not come. In this case, data link layer will be again responsible for error correction. Then again, this node will transfer that data. Fine. That's why I have already taught you about the data link layer, it is a feature of data link layer that it corrects the error. Okay.
So
What is yes?
is initially any IP address is provided by the node or not?
Initially, yet initially provided by the node.
Which type?
Initially means what is your initial point?
Like from where the data is started to speak.
From where the data is
Started to some.
started to send. Okay, fine. Means just you can say here
Not
only this part.
so only node that computer.
That computer. Look,
It is the initial part.
it is the initial part. This part has to send the data. Then it should mention MAC address and IP address both. Next node IP. Next hop route IP.
Next hop.
Hop.
Then how will you recognize that router's IP is that?
Route. Look, my dear. You have concept of default gateway.
Yeah.
Default gateway. Suppose I have to configure an IP address at this node, then the IP of this node will be 10.0.0.2 because it belongs to 10.0.0.0 network. And we have given IP address 10.0.0.1 at router. Then we can use 10.0.0.2, 3, 4, 5. These IP addresses will be configured at different node of this network. Right? But with this IP, we also provide subnet mask 255.0.0.0. And just below the subnet mask, we give default gateway address. And default gateway address is router's address. Because if you have to communicate with different network, you must have default gateway address.
Yes.
Without default gateway, your node will not communicate to any other network. Now, it is clear?
Yes.
Yes, read.
So if we treat the computer address of IP or use default gateway, it does not know that where is the destination.
Definitely, it does not know where is the destination. Just.
Then it will send the data onto the switch only.
Not only onto the switch. Definitely, a node transfer data to the switch on.
That's right.
It is not responsible for transferring data to the destination network because this for transmission to the destination network, router is responsible because it is a feature of network layer. Network layer is responsible for transmission between source and destination network.
Switch sends the data.
Switch is responsible to establish connection between two or more different nodes, local node, LAN node. But there is a property also that switch broadcast. Fine. If switch is not able to get information about the destination node, because for communication, what switch does? Switch just checks its MAC table. Huh? But Z will be available into the MAC table.
No, sir.
No. Because Z is available here.
Yes. Yes.
Fine. That PC information is only available with this switch. Now, in that case, what switch will do? Switch will broadcast. Then your data will be transferred to all nodes as per the switch nature, switch function, and also to this point. Fine, because you have connected this router to your switch.
Yes.
When this router will get this broadcast message, then it will check the destination address, and destination address is this.
First.
Why switch has broadcasted this message to this point? Because you have already mentioned the default gateway address. Yeah, I have default gateway. Now switch has broadcasted and router has received this broadcast message into the gateway. That's why gateway is very compulsory. But the actual destination IP is this 172.16.0.2. No, route doesn't give the acknowledgement to the switch because it is a broadcast. Fine. Now destination address is this, but at this point, router will check that this network information means 172.16.0.0. This information is available into the routing table or not? Yes, it is available, because in routing process, every router has information about all different networks available into the whole scenario, right? But if router will check that, okay, 172.16.0.0 network is present in my routing table, which subnet mask is 255.255.0.0. But at the same time, router sees that, okay, for communication to this network, I have to transfer data to next hop router address, that is 11.0.0.2. Please recall the static routing concept. In a static routing, I have taught all these things. When router will find, okay, I have to just transfer this data packet to this hop, and this hop is second router, router 2. Now your data packet will be transferred from router 1 to router 2. Now router 2 will again do the same thing. When it will check 172.16.0.0 network information is available into my routing table. So yes, it is available. This subnet mask is this. But what is the next hop router address? Next hop router address is its own interface, that is fast Ethernet 0/0, not an IP address. Then it will transfer this data packet to this interface. This is fast Ethernet 0/0. Then again, this packet will reach to this switch. Switch will check the MAC table to find out this Z node. Then you get information, okay, Z node is available into at 1, 2, 3, 4, any port. For example, 4 port. Then data packet will be transferred to the particular port number 4. Port number, this one is the port number 4. Fine. It means there are many change with the IP address. This is the IP packet. How does our IP packet work? That's why during your CCNA class, I will teaching everything. Just see, just do practical. Do practical. Fine. I think you all are facing trouble to recall your previous class.
Yes.
Okay, fine. Now, for the IP packet transmission, data packet transmission, look, go through the network layer is totally based on your CCNA syllabus, routing part of it. Because I have to teach here NATing. I have already taught you what is NATing. I have done practical on all these things. Fine. IP transition, for IP transition, I have already taught you IPv4 and IPv6. Logical addressing, IPv4 and IPv6. Otherwise, if I am going to repeat all these things again, then it will take approx 10 classes. I have started brief explanation of different topics. Finally, you all have punished me. Sir, our paper is delayed. Huh?
So it is not.
Yes.
It is his paper is not.
Look, my. If I wanted, I can start from that point. I'm not going to explain about that point. I should start from network layer, but I have started from beginning. Beginning. Okay, no issues. Look, I will give you brief explanation, but that will be brief only. Okay, fine.